Assalamu alaikum students. Today's topic is going to be about numericals of chapter measurement. Let us look at the first numerical. A circular pizza into 3 equal parts. One piece of the pizza is taken out. Estimate the degree of measure of the single piece of pizza and convert the measure into radian. What is the radian measure of the angle of the remaining part of the pizza? So let's say this circle represents the pizza. In the question, it says that we have to divide the pizza into 3 equal parts. And we have to measure the angle of one side of pizza in the form of radian, that how much radian it is. And the second part says how much is the rest of the pizza. So let us look at the data which is given to us. It says over here number of pizza of a circular pizza is 3. So that means the whole pizza was of radian 2 pi and we have divided it by 3. So the angle subtended by one pizza, we have to figure it out. And the angle subtended by the remaining part of the pizza, we have to also figure it out. So angle subtended by the circle, that is pizza, is theta is equal to 2 pi radian. That means this whole pizza is representing the circumference of the pizza. Now, angle subtended by one of the 3 pieces, that means we have to divide the 2 radian, which is given over here, by equal 3 parts. So we'll get the value of one part of the pizza. So let us put in the value of pi, which is 3.14. So 2 multiplied by 3.14 divided by 3, we get the radian, which is 2.09 radian, which was of one side of the pizza, like over here, this side. Now for the rest of the angles, what do we do? The angle subtended by the remaining 2 pieces of the pizza, what do? We multiply this value by 2 because all the pieces of pizza have the same value. So 2 multiplied by 2.09 radian will be equal to 4.18 radian. And that is our answer as well. Question number 2 says a length of a pendulum is 1.5 plus minus 0.01 meters. And the acceleration due to gravity is taken into account as 9.8 plus minus 0.1 meter per second square. Calculate the time period of a simple pendulum with the uncertainty in it. So first of all, the data which is given to us is length, which is 1.5 plus minus 0.01 meters. We have the acceleration, which has a value of 9.8 meter plus minus 0.1 meter per second square. So you can see the precision over here is different. The value of significance is different. So we can't basically just add or multiply. We have to remember the formula of time period. So T is equal to 2 pi under root L over G. Now there's a power over here as well. We can write down this one as T is equal to 2 pi. Instead of under root, we can say L over G into 1 over 2. Let me write down it clearly. So T is equal to 2 pi. Instead of writing under root, we can say 1 over 2. Now, this is the power, and we can multiply the power with the percentage uncertainty over here by adding up all the percentage uncertainty of the length and the gravitational acceleration, and then multiplying it by 1 by 2, we get the value. So the percentage uncertainty in the case of time, we'll find that out by this using this formula. T is equal to 2 pi under L over G. Now in this case, we have the value of certainty. So 1.5 was a certain part and 9.8 was a certain part. So let us put in the value and find out the value of T. So it is 2, which is the value of 2 as well, which is a constant value. 3.14 is the value of pi. The value of L is 1.5. The value of G is 9.8. Now, if we calculate it, it will be 2.5 seconds. This is the value of certain time. Now for the uncertainty part. First of all, we have to find the uncertainty in length, which is delta L divided by L multiplied by 100. So it is 0.01 as it is written over here, divided by 1.5 multiplied by 100. So that is the value which is coming to 0.67%, which is the uncertainty in the case of length. Now for the case of G, The percentage uncertainty in the case of G is delta G divided by G multiplied by 100. So let us put in the value. It is 0.1 divided by 9.8 multiplied by 100, which is equal to 1.020. Now, if we add up these two numbers, the percentage, and we multiply it by the power of these values, that means 1 by 2, we'll get the value of the total uncertainty in this whole case. So the formula of the time period, as we know, is known as T is equal to 2 pi under root L over G. Similarly, we can say 2 pi, we can say L over G 1 over 2. So the percentage uncertainty of T will be given as 1 over 2, which is the power, multiplied by percentage uncertainty of length plus percentage uncertainty of T. So it will be 1 over 2 multiplied by value of L was 0.67 plus value of G was 1.02. If we basically add them up, it will be 1.62. And if we solve this one, it will be 0.81%, or for simplicity, 0.8%. Now, this is the percentage uncertainty of T, and this was the certainty of T. So our answer will be T plus minus delta T will be equal to 2.5 of the certainty plus minus how much was the percentage uncertainty. So over here we'll say it is 0.8%, and that is our required answer, and that is how we get the answer for this case. Moving on to question number 3, it says determine the area for a rectangular sheet with the length L plus minus delta L, which is 1.5 plus minus 0.02 meters, width of W plus minus delta W, which is 0.20 plus minus 0.01 meters. Calculate the area, which is area plus minus delta area, which is we have to find it out. Now, the data which is given to us, which is L plus minus delta L is equal to 1.50 plus minus 0.02 meters. The width which is given to us is W plus minus delta W is equal to 0.2 plus minus 0.01 meters. Now we have to calculate the area and along with this uncertainty. Now in this case, calculate the area. We have the formula of area for rectangle, which is area is equal to length into width. So let us put in the length, which is 1.5. Let us put in the width, which is 0.2. The answer comes out to be area is equal to 0.3 meters squared, because it is an area. Now we have the certainty. For the uncertainty part, first of all, we calculate the uncertainty of length. So percentage uncertainty in L is delta L divided by L multiplied by 100. Let us put in the values. So 0.02 divided by 1.5 multiplied by 100. It turns out to be 1.33%. Now for the case of width, the percentage uncertainty in W or delta W divided by W multiplied by 100. The values are 0.01 divided by 0.20 into 100. Our answer comes out to be 5%. Total uncertainty in this case, we have to add up. So if we add up the two percentage uncertainty, that means the percentage uncertainty of the length as well as the percentage uncertainty of width, we get the percentage uncertainty of area. So let us put in the value of 1.33 plus 0.5%. We get the value of 6.33%, which is the uncertainty part. But this is percentage. We have to calculate the values in the quantity. So what we do for that? The absolute uncertainty area is calculated as we convert that percentage into quantity by 6.33 divided by 100 multiplied by 0.3. That means we have to find the percentage uncertainty out of 100 and then multiply by the certainty of that case, which is 0.3 meters. Now, if we do that, we have the value of 0.018 meters squared. Or if we round it off because it is greater than 5, so it will be 0.02 meters squared. Now, this is the uncertainty in the case of value, and we have the certainty, which is 0.3. So now let's add them up. It will be the area for a rectangular sheet will be A plus minus delta A will be equal to 0.30 plus minus 0.02 meter square. Moving on to question number 4. It says over here, calculate the answer up to appropriate numbers of significant digits. So all of them are significant, but we have to choose the least significant figure. Like in this first case, the least significant is 98.3 because it has the least significant figures. Over here we have 1.4. Over here we have up to 3 significant figures, and after decimal there are 2 digits. Over here we have 3 and 2. Over we have 1 significant figure as 9. Over we have 4 significant figures. So we have to write down the answer in this special form. Keeping that in mind, let us solve for the first one. So 246.24 plus 238.278 plus 98.3. If we add them up, it will be 582.818. Now 582.8 has least 1 decimal place. That means in this case we can say it has at least 1 decimal place. That is why we have to place it at least 1 decimal place, and we have to round it off all of the another values which are after the decimal. If we move on to the next question, it says 1.4 plus multiply by 2.639 plus 117.25. Our answer will be written as 3.6946 plus 117.25. If we add them up, it will be 120.9446. So how many decimals? Sorry, how many digits were after the decimal? Only 1. So we have to keep only 1 decimal over here. And 4, as we know, it is less than 5, so we don't have to carry anything. So our answer will be 120.9. If we move on to the next part of the question, it says 2.66 multiplied by 10 to the power 4 minus 1.03 into 10 to the power 3. If we write them in the normal form, it will be 26,600 minus 1,030. So if we subtract them, it will be 25,570. But how many digits were written significantly? So we have 3 digits, and as we convert them into scientific form, it will be 2.5570. Now this is a scientific form, but we have to write down only 3 significant figures. So you can see over here there are 3 significant figures. So 2 is a significant figure, 5 is a significant figure, but this 5 we have to round it off. So 7 is greater than 5, so it will be 6. So our answer can be written as 2.6 into 10 to the power 4 as the least decimal places. That means 3 least decimal places is given. Now in this case we have another question. It is 112 multiplied by 0.456 divided by 3.2 into 120. So let's calculate. It is 51.072 divided by 384. It is 0.133. So how many significant figures were there? There were only 2. So we can say that it is 0.13 and has at least 2 decimal places, which is given because it has only 2 significant figures, 3 and 2. Now for the second last question, which is E, which is 168.99 multiplied by 9. So over here, the significant figure is 9. So the answer must also be in 9. But that means 1 significant figure. So it will be answer of multiplication of these two. It will be 1520.91. Now this is not insignificance because only 1 digit was required. Over here we have 1, 2, 3, 4, 5, and 6. Now, if we want to round it off, it will round it off to only 1 number, which is the last number of the value, which is 1. So how can we round it off? We can round it off to the power of 3. So we can represent it 2000 as the data or the data least significance to digit, or we can say, so it is 1520.9. So it is rounded up to 2000, which contains only 1 significant figure because in the question it was given only 1 significance digit. Or we can say it like 2 into 10 to the power 3. So we can show it over here that it is only 1 significant digit. So the last question says, it says for this question, which is 1023 plus 8.5489. So if we add them up, it will be 1031.5489. And as you can see, 5 is over here, so we round it off so that it comes into only 4 significant figures. So it will be 1032, and that is our answer. So as the given data is 1023 has no decimal places, so the answer also or do not have any decimal places. That is why our answer is 1032. Question number 5, calculate the answer up to appropriate number of significance, the ratio of mass of a proton and mass of an electron. Let us put in the value. The mass of a proton is basically 1.67 into 10 to the power minus 27 kilograms. Mass of electron is basically 9.1096 into 10 to the power minus 31 kilograms. You can see it clearly that this is the mass of a proton and this is the mass of a electron. Now solve it. Now we can see very simply that this 3 significant figures are given. Now, if we calculate, it is 0.18332 into 10 to the power 4, because kilogram will cancel with each other, so they are dimensionless. Now, in this case, only 3 significant figures are required. So we can write down in scientific form, or we can say 1.8332 into 10 to the power 3, because one decimal has been carried over here. Now, only 3 significant figures are required, 1, 2, and 3. So over here, 1, 2, and 3 significant figures are required. Other than 2 significant figures or 2 numbers or the 2 digits basically are removed. So our answer will be 1.83 into 10 to the power 3. That is our answer. Answer should be up to 3 significant figures, as these are least significant digits in the given data. Now, the second part of this question says the ratio of a charge, which is QE, to the mass of electron, which is ME. Now, charge of electron is 1.6 into 10 to the power minus 19 coulomb, whereas the mass of electron is given right over here, which is 9.1096. So let us put in the values and find it out. So Q over M is 1.6 multiplied by 10 to the power minus 19 coulomb divided by 9.1096 into 10 to the power minus 31 kilograms. So if we divide them, what do we get? We get 0.175688864 into 10 to the power 12 coulomb per kilogram. Only 2 significant figures are required. So over here, we can say that only 2 were required. First of all, we convert that into scientific form. It is going to be written as 1.875633388864 into 10 to the power minus 11, because we have moved the digit to one side, so the power becomes less. Now, if we see only 2 significance digits were required, so all these digits will be removed, as 5 was converted into 6, as this 6 is greater than 5, so it will carry, it will be 1.76, and 6 is greater than 5, so it will be written as 1.8 into 10 to the power 11 coulomb per kilogram. You can say it like that. So let us write it down clearly. So it will be 1.8 into 10 to the power 11 coulomb per kilogram. This is our required answer for this one. And the reason for this is the answer should be up to 2 significant figures, as these are the least significant digits in the given data. Question number 6 says find the dimension of Planck constant, where the formula is E is equal to HF, where E is the energy and F is the frequency. So first of all, we must know the dimension of energy. Energy is equal to be, let's say, potential energy, mgh. So m will be written as m. G's dimension is basically meter per second per second, so we'll say L T inverse square, and the value or dimension of h is basically length, so it is length. So dimension of E is basically m L square, because this L will multiply with this one, so it is L square into T square. This is the value of E. And as we know, frequency is the inverse of time period, so we'll say the dimension of time period as well, or we can say T inverse. So these are the 2 dimensions which we are going to basically form to find out the value of Planck's constant, which has the value of 6.6 into 10 to the power minus 34. So dimension of Planck constant basically is from the equation E is equal to HF. So H will be equal to E, and as I told you over here, the dimension of E is equal to mL square T inverse square divided by the frequency part, which is T inverse. If we take this T inverse to the top, it will be ml square t minus 2 dimension, and this t goes over there, it will be minus 1 to raise power minus 1. So ml square t square, we can say minus, it is t to raise power plus 1. So this t and this t over here basically multiply with each other and the power will add up. So it will be minus 2 plus 1 t. Now in this case, ml square minus t, and that is going to be the dimension of Planck constant, which is written right over here. So ml square t inverse, that is the dimension of the Planck's constant. Now the next question says, B part the gravitational constant G from the formula F is equal to G m1 m2 over r square, which says the force of gravitation basically is directly proportional to the product of the two masses and inversely proportional to the square of the distance between them, where G is the constant value and has a value of 6.6 into 10 to the power minus 11. We can say Newton meter square divided by kilogram square, but we have to find the dimension of G. What is the dimension of G? Now, where F is the force, m1 and m2 are the masses, and r is the distance between the objects, or we can simply say G is equal to F r square divided by m1 m2. If we put in the dimension of F, so as we know, F is equal to ma, m has the dimension of mass, a has the dimension of L into 10 to the power minus 2, so it is mlt inverse square. R has a dimension of L square, and mass has a dimension of m, and this mass has a dimension of m as well. Now let us solve this algebraically very simply. So it will be giving us the value ml cubed multiplied by t square divided by m square. So if we multiply these two m, it will be m square, L will multiply by this one, so it becomes L cube. Now solve this one if we can. So it will be m goes up, it will be 1 plus minus 2 because it is going up, L cube into t square. Our answer will become minus m L cube minus 2. This is going to be the dimension of G. So it will be m raised power minus 1 L cube into t minus square. Moving on to the last question, it says shows that kinetic energy is half mv square and potential energy is mgh are dimensionally correct. So we have to equate them both to a certain value which we already know, which is work done. So if the work done dimension is equal to kinetic energy and potential energy, then they too will be dimensionally correct. So first of all, for the kinetic energy as we know is half mv square, where m is the mass and v is the velocity. Let me write it clearly. So here we have velocity, and here we have the mass. Now in this case, we are comparing it to work, and work is equal to force into displacement. So we know the dimension of force, as we know force equal to ma. That means according to the second law of Newton. So m will be mass, a will be L t minus 2. So this is the value of F, and D basically is representing the length, so it is L. So combining them together, it will be m L square t 2 raised to power minus 2 square. So this is a dimension of work done, which we have to calculate over here. So here we go. So it is mlt square, where it is a dimension of force, where L is the dimension of t. So if we add them up, let me clearly write it down. So if we add this L and this L, it will be L plus L, it will be 2L. So the dimension of work done will be m into L square into t square. Now for the right hand side, this side. So if we take the right hand side of this equation, it will be half mv square. So we don't consider the magnitude part, we don't consider it. So m basically will be written as m, and v, as we know, it is meter per second, the units are. So it is L divided by t whole power square, because there's square over here. So it will be m L square t square. So as you can see, the left hand side as well as the right hand side, this is the left hand side and the right hand side, both of them are equal. So this proves the concept of homogeneity. That means these are dimensionally correct. So kinetic energy checks out that it is dimensionally correct. What about potential energy? So First of all, we say the dimension energy of left hand side and right hand side are same, so the given equation is dimensionally correct. But what about potential energy? So potential energy is mgh. So first of all, we compare it to work done. So left hand side will be potential energy, will be equal to work done, which is F into D. Again, the dimension is going to be same as that of over here. So it will be M L T inverse square and into L because it is D. So it will be given same procedure over here. L will be multiplied by this L. So it will be L plus L to raise power 1 plus 1 and M L to raise power 1 plus 1 into T square is equal to M L square T inverse square. Now in the next case, we have the values of the right hand side, which is mgh. M will represent the mass, G will represent the acceleration, which is LT inverse square, and H will be L. So if we put in the values and multiply, what do we get? This L will multiply with this L, it will be L square. So ML square and T inverse square. So as we can see, the left hand side is equal to the right hand side. So in this case also the homogeneity is basically fulfilled. We say is also dimensionally correct. And here's we can say since dimension of left hand side and right hand side are equal to each other, so the given equation are dimensionally correct. I enjoyed today's lecture. Inshallah, we'll meet again. Allah Hafiz.